Hi, I'm David and welcome to What Circuit. For this video we've been given the opportunity to come down to the Motiv8 Forums down in Oxford, which are being held at the Williams F1 Centre, as you can see behind me. We've had a chance to talk to some of the exhibitors and see some of the exciting stuff that they're bringing out at the moment. So without further ado, some of the exhibitors. So first of all we're talking to some of the guys from Nanotherm, so can you just tell us a bit about who you are and what you do?
I'm John Cafferkey, I'm Marketing Manager for Cambridge Nanotherm.
I'm Giles Humpston, I'm the Field Applications Manager.
And what do we do? Well, we are Cambridge Nanotherm, we're actually based in Haverhill in Suffolk, and we manufacture nanoceramic substrates which are designed for LEDs and other high power electronics. This is an example here. It's a PCB in essence, aluminium with a coating of nanoceramic on it. This is done using a process that Giles will describe and take us through. We sell this into companies like LED luminaire manufacturers and LED packaging, so sub-mounts for LEDs. There are various ways of actually transforming this into a board, which is, well, depending on the target market we're looking for and depending on how much money people have to spend. But Giles is our technical guru, so I shall hand over to him to describe.
So what are some of the advantages of your technology over the existing solutions out there?
Well, what we're interested in particularly is good thermal conductivity. So we have an issue with, you have say, an array of LEDs on a board like this and you want to get the heat out. But you also want to get electrical connections to the LEDs. So you can get the heat out easily if you use an aluminium panel, but you need to get the wiring traces to the LEDs. Now you can put some copper circuitry on the top, but if you put that directly onto the aluminium, it will short out. So you need an insulator between them. Now the traditional method of doing that is to use a polymer, which is great as an insulator, both electrically and thermally. So you can't get the heat from the LEDs into the board. So what we do is we convert the surface of the aluminium to alumina, basically, nanocrystalline alumina. Now alumina has a really good dielectric constant, or breakdown voltage I should say. So you only need a very thin layer to get the electrical isolation between the copper and the aluminium, and that means you get very good through thickness thermal conductivity. And our basic boards are about 20% better in thermal conductivity than anything else you can get today.
So to achieve a typical industry standards, dielectric withstanding strength, you can just do it with a much thinner layer. So it's just much better conductivity for thermal side.
Our breakdown voltage is around 50 volts per micron. And typical products, depending on the application, are either 10, 20 or 30 microns in thickness of nanoceramic, which is adequate for most applications.
That's excellent. So is this just a drop-in replacement for the existing technology out there?
Yes, exactly. All we do is we take the aluminium, we grow our nanoceramic on the surface, so it looks slightly dull grey, and then we do this on great big panels, and then we pass them into standard PCB assembly houses who work their magic in the conventional manner.
So it just goes through a completely conventional pick and place machine, no change in contract electronics manufacturer required?
None at all, yep. And yes, we have a number of PCB houses that will do this for you.
That's really interesting. What kind of degrees C per watt thermal resistance can you get across, say, a typical application that, say, you're melting a LED on a board?
That's actually quite a difficult question to answer, but the thermal performance of our boards, certainly our latest products, they are equivalent to aluminium nitride in thermal conductivity. So you're talking a through thickness thermal conductivity of around 150 watts per meter Kelvin, which is very substantial.
That's excellent. And I see, a lot of your literature, you seem to be sort of focused on the LED market at the moment. I presume that's a really big area for you at the moment.
Yeah, it's obviously a big growth industry, but there are lots of applications in LEDs where you have very high power densities. So this is a fairly typical application that we have. So these are boards on which you put a little array of LEDs, but these LEDs will be running at about 75 watts. Now, while that's a big number in itself, this particular board is designed for UV LEDs, UVC LEDs, and these are very, very inefficient compared to the normal white lights that you see. So the LEDs may only be running at about 5% efficiency. So basically this is an electrical heater. So you've got sort of 70 odd watts of heat that you need to get out of a tiny little board like that. So you need to get the heat into this and then away into your heat pipe or a heat sink as soon as possible. And that's where our product really scores.
And you can get the heat out of that local area, so you can get the LEDs right where you need the light. Presumably you can get your heat sink further away using this technology much better than what's out there at the moment.
Exactly. And our latest version of this product is completely free of all organic materials, which means it can operate at much higher temperatures, it's much more robust, and if you're thinking about exotic applications like space, there's no outgassing.
That's really nice, yeah. Interesting. Also, have you looked at doing this into any other applications or any other areas?
Yeah, anywhere where there's a thermal problem from electronics is basically the answer. So, as you say, while we are focusing on the LED market initially, because it's a growth area, we have done all sorts of interesting things. I mean, this particular board happens to be an audio power amplifier, but it's just the same problem. It's power devices that are getting hot that you need to get the heat away from, otherwise bad things happen. We can also use our technology for some very interesting things. Very occasionally we'll get customers coming along to us and they'll have a large aluminium component or aluminium silicon carbide that's been machined, and they'll want a dielectric coating on one particular area, usually for some exotic reason, and we can actually put those through our process as well and just grow a dielectric in one particular area.
Excellent. So do you also do the manufacturing of the PCBs effectively in your facility? So do you do all the growing yourselves?
It is. It's all done in the UK, in Haverhill. Yes, we have our own production facility, and everything goes out the door.
Excellent. Well, thanks very much for your time. That's really interesting.
Thank you.
Thank you very much.